So surds are root numbers which cannot be expressed fully as terminating decimals or recurring decimals. For example, root 2, root 3, and root 7, among other examples. So we want to discuss all of it, see what you need to know and how you need to solve questions involving the surds. So first, simplifying surds. Examples: we have simplify root 56. So in this, you look for two numbers. One should be a perfect square. How do you simplify this? You look for two numbers. One should have it should be a perfect square, and the other one should not. So we have 8 and 7. So we have 4 multiplied by 14. So in this, now you separate these two. You'll have root 14 multiplied by root 4 multiplied by root 14. But we know root 4 is 2, and root 14 will remain as it is. Another example, maybe you have root 120. So how do you solve this? So for root 120, two numbers, whose product will be 120, and one is a perfect square. We have 44 multiplied by 30. So similarly, we'll have root 4 multiplied by root 30, and this one is 2 root 30. Number 3, root 72. Two numbers here, we have 2 times 36. So this is root 2 multiplied by root 36, and this will give you root 2 multiplied by 6, and this is 6 root 2. So we have many examples, and this is how you do it. You get two numbers whose product will be the surd given. One of the numbers should be a perfect square, so that you get the square root and then multiply that one. Thank you. Addition of surds and subtraction. Just like algebra, surds can also be added or subtracted. So examples: if you have root 3 plus 3 root 2 plus 4 root 3. So you collect those with the same roots. So root 3 plus 4 root 3, then plus 3 root 2. So this one, you add, you take it, you let root 3 equals to a. So it will be a plus 4a, and this is 4a. So your answer will be 4 root 3 plus 3 root 2. That's how you add. Another example, maybe you have root 5 minus 3 root 7 plus 7 root 5 plus 9 root 7. So how do you solve this? You let a equals root 5 and b equals root 7. So this one will be a minus 3b plus 7a plus 9b. So like algebra, this will be a plus 7a plus 9b minus 3b. So this is 8a plus 6b. But our a is root 5, so 8 root 5, and b is root 7, so 6 root 7. That's how you solve your surd. Multiplication. How do you multiply surds? Let's say you have root a multiplied by root b. This will give you root a times b, which is root ab. Example: root 13 multiplied by root 2. This will be root 13 times 2, and this is root 26. That's one. Number 2, if you have 3 root 5 times 4 root 7, how do you solve this? It's just like algebra. You let a equals to root 5 and b equals to root 7. So we have 3a times 3a4b. This one is 12ab. So meaning this is 12 root 5 times root 7. This one will be 12 root 35. Another example: 4 root 8 times 9 root 15. So how do you solve this? Of course, whole numbers you multiply them, so we'll have 4 times 9, which is 36. Then the roots, root 8 times root 15. This will give you root 120. And this will be now 36 times root 120 is equals to 36 root 120. You simplify this. as we did earlier. This will be 36 times 2 root 30. This is 72 root 30. Fractional surds. Simplify. 1 over root 5. How do you simplify this? Or in some words they say rationalize. Rationalize. So we know the surds are not rational numbers. To make the denominator a rational number, how do you solve this? So if you have 1 over root 5, then this can be 1 over root 5 times root 5 over root 5. Remember, this is 1. You can simplify to get 1, so there's nothing doing to it. So this 1 times root 5 is root 5. Then root 5 times root 5, that is root 25. And this is root 5 over 5. So 1 over root 5 is the same as root 5 over 5. This is number 1. Number 2, if you have 2 over root 2 plus 3, how do you rationalize the denominator? So for this, now we come into something we call conjugate. Conjugate means you interchange the sign, you change the sign. If it is addition, then the conjugate will be root 2 minus 3. You change the sign. Then you multiply root 2 over root 5, root 2 plus 3, multiplied by root 2 minus 3 over root 2 minus 3. So numerator, we will have 2 root 2 minus 6. Denominator, it is root 2 squared minus 3 squared. And this one will be 2 root 2 minus 6 over 2 minus 9. And this one will be 2 root 2 minus 6 over negative 7. This part, we had root 2 plus 3 multiplied by root 2 minus 3. From algebra, we know S plus B, A minus B. If you multiply this, you're going to get A minus B squared. Difference of two squares. That identity is the one that you apply here. Number 3, 4 over root 5 plus root 7. How do you rationalize this? So this will be 4 over root 5 plus root 7, then multiplied by root 5 minus root 7 over root 5 minus root 7. This will be 4 root 5 minus 4 root 7 over root 5 square minus root 7 square. So this will give you 4 root 5 minus 4 root 7 over 5 minus 7. And this will be, final answer will be negative 2 root 7 minus 2 root 5. The denominator is in an expression. For example, you have 3 root 5 plus root 2 plus 3 over root 7. How do you solve this? So the first thing, you solve the first expression, then the second expression. So this will be 3 root 5 plus root 2, then multiplied by 3 by root 5 minus root 2. The conjugate, root 5 minus root 2. This will be 3 root 5 minus 3 root 2 all over root 5 square minus root 2 square. So this will give you root 5 minus 3 root 5 minus 3 root 2 over 5 minus 2. So this will be 3 root 5 minus 3 root 2 over 3. So solving this, we'll have root 5 minus root 2. So the second part, 3 root 7. This one is root 7 by root 7. So we'll have 3 root 7 over 7. So you add to this, we'll have root 5 minus root 2, then plus 3 over 7 root 7. 3 root 2 minus 4 over 2 root, you can say 3 plus root 11. So how do you solve this? We will have 3 root 2 minus 4 over 2 root 3 plus root 11. Then this one, multiply it by the conjugate of that, which is 2 root 3 over minus root 11. 2 root 3 minus root 11. So the numerator, we will have 3 root 2 into 2 root 3 minus root 11 minus 4 into 2 root 3 minus root 11. Then all over. Of course, the denominator is 2 root 3 square minus root 11 square. So at the numerator, it is 6 6 root 6 minus 3 root 22 minus 8 root 3, then plus 4 root 11 all over 4 times 3, that is 12 minus 11. So we will have at the numerator we have 6 root 6 minus 3 root 22 minus 8 root 3 and plus 4 root 11. That's the answer there.